All right. Hi, thanks for watching. In this video, I'm going to go over the solutions for worksheet 5.1. So here we go. So first one is the elevator is moving at a constant velocity, so that's the most important part. The actual speed itself, the velocity does not matter because it doesn't really matter how fast you're going. As long as you're moving at a constant velocity, then your acceleration is equal to 0. So that's kind of the only thing we're really concerned about here. So the first thing it says is construct a force diagram for the person in the elevator. So obviously the person in the elevator is going to have the force of gravity acting on them, but then and then the normal force, the force of the floor pushing up against them, is going to be there as well. Those are going to be equal to each other because they're moving at a constant speed, so the net force would need to be 0. So what force does the floor exert on the man? For this, you would just do, you sum your forces in the y direction. Because you're moving at a constant speed, those are going to cancel each other out. Your net force is going to be equal to 0, and that just gives you that normal force minus the force of gravity is equal to 0. So add the force of gravity to the other side. Force of gravity is equal to normal force, which is mg normal force. So normal force 2 m, which is 85, times by g, which is 9.8. 85 times by 9.8 is 833 newtons. Cool. Moving along. So now it's accelerating upwards. So draw a new force diagram. So we have the same force of gravity here, but now we're going to have a bigger normal force. And move that down a little bit here. Okay, so next up, now we need to solve for the normal force again. So this time we are accelerating. So when we sum our forces in the y direction, we will have an MA, a net force, and then that's going to be your up forces minus your down forces. And we are solving for the normal force. So I'm going to add the force of gravity to the other side. So I'm going to get MA plus the force of gravity is mg. So I'm going to go ahead and plug in mg right now. Normal force. So still the 85 kilogram guy. The acceleration is 2 meters per second. So let me plug that in. Again, 85 kilogram person, 9.8 meters per second squared is gravity. So when we plug all that together, 85 times by 2 plus 85 times by 9.8 is going to give you 1,003 newtons. So again, noting that the force of gravity is bigger than the force, the normal force is bigger than the force of gravity, right? Because this is 1,003 newtons and the force of gravity is only 833 newtons. So now we've reached the top of the building. So our acceleration is, we have a downward 3, acceleration of -3. So as it's slowing down, right, the velocity is going up, like has an upward velocity, but we're slowing down. So that means we actually have a negative, like this is a downward acceleration. So it's going to be an acceleration of -3 meters per second squared because it needs to have the same sign as gravity in this. So they're going to both be negative. So it says construct a force diagram. So we have the same force of gravity that we had in the other two problems, but now we're going to have a small normal force. That's what gives us our net force downward. So gravity itself isn't actually changing. The normal force is. And so now it's getting smaller. So again, we sum our forces in the y direction. Again, it's accelerating, so we're going to have ma as our net force, and then again, that's going to give us the normal force minus the force of gravity because those are our only two forces. So let's see here. Again, we're solving for the normal force, so I'm going to add gravity to the other side. In this case, right, M is, oh, hang on, I'm going to change that to mg. So we got our 85 kilogram person, our acceleration. Now here's the trick, right? -3 meters per second squared because it's accelerating downwards, right? So then we got the 85 times by the 9.8 there. When you plug that all in, right, your force of gravity is obviously 833, but then you're going to ultimately end up subtracting the 85 times by -3 just because it's negative. So it's 85 times by 9.8. And that's going to give you a normal force of 578 newtons. So, right, I mean, this is 833, 85 times by -3. That gives you a -255, right? So next, while descending in the elevator, the cable suddenly breaks. What is the acceleration as falls, right? So anything that is falling has an acceleration of -9.8 meters per second squared, right? So that's anything falling on Earth has that acceleration. So if we basically, this is the same situation as number 3. So when we go to plug things in, right, we have 85 times by -9.8 as, right, again, our the acceleration as it falls, plus the force of gravity. That's 85, not 50, sorry. 85 times by 9.8. Not negative, because we took care of the negative sign, like here, basically, right? So we've already taken care of the negative sign there. So the normal force, and right, we're going to get that the normal force is equal to 0 newtons. And if you think about that, it makes a certain amount of sense, because if you were falling, right, like the elevator is falling, you are falling, everything is falling, and so therefore, right, it makes sense that the elevator can't push up on you because it is also falling, right? So if everything's falling together, the elevator can't possibly apply an upward force on you because, right, you both are in free fall. So okay, so now we have a person has a mass of 68 kilograms, is descending in an elevator at a constant speed of 4 meters per second. Again, the velocity doesn't really matter in this case. The only thing that matters is that it's a constant velocity, which is 0. Then at some time t, the elevator starts to slow to a stop at a rate of 2 meters per second. So first up, draw a force diagram. So if he's going at a constant speed, so this would be for constant speed. And this would be for acceleration. This would be its slowing down. So in this case, right, we got our force of gravity, and that's actually going to be the same in both of them, because it doesn't really matter whether you're speeding up or slowing down. The acceleration or the force of gravity is the same. If you're moving at a constant speed, then I got to have an equal force to cancel that out. So that's going to be the normal force there. But in this case, if I'm slowing down, right, if I'm going downwards but slowing down, that means I need to have a net upwards force on that. And so it's got to look like that. So that seems kind of weird, but if you're going down but slowing down, you have a negative velocity. To slow down, you need to have a positive acceleration. Again, go back and look at your acceleration notes to check that out if that's confusing for you. It does say a quantitative force diagrams. I'm going to come back and put the numbers on it in a second, but I'm going to go ahead and do part B here first, and then I'll come back and put the numbers on. Basically, at a constant, right, to figure out the what did the scale read when the elevator was descending at a constant speed. So constant, we'll do that one first. So if you're going at a constant speed, your net force is going to be equal to 0. That's going to give you the normal force minus the gravity, and add the force of gravity. $68 kilograms, I believe. 68 times by 9.8, the normal force. So 68 times by 9.8 gives you 666.4. Okay, and then while slowing to a stop, again, we still have the normal force up and force of gravity down. So we got 68 kilograms. Let's see here, what is its acceleration? 2 meters per second, so that's an upward acceleration of 2. So 68 times by 2, 136, plus, right, you're going to add the 68 times by 9.8, so 68 times by 9.8 is the 660, so 666.4 equals your normal force. Normal force is equal to the sum of those two, 802.4, 802.4 newtons. So, all right, there you go. So of course we can go back and put, these are both 66 or 666. This is also 666.4. And this is our 802. So there you go. All right. Well, thank you very much for watching. Hopefully you found this useful. And as always, let me know if you have any questions on it. Thanks. Bye.